Yo. What's up? Welcome back. Today we're working on our QR code decoder that we're writing from scratch. And today's topic is attempting to make it work on big QR codes. So what we have so far is we generated some QR code on like DuckDuckGo. We just typed in like QR code hello world, and out comes this guy. And we've been kind of using this as our sample for now. And here's kind of where we're at. So we can find these like finder locations because if you look at this picture, there's like some white border around there as like is required by QR code spec. And so the first thing we have to do is like figure out where the fuck the grid is, right? And so we kind of can like walk one-dimensional scan lines and try to find where we think there could be a finder pattern. So that's what these like red and blue dots are in the here. We look for like the intersections of those dots, and we can find like the center of the finder. Great. From there, we can draw boxes around the finders. Those are looking good. Those are the yellow lines here. From there, we can draw a red box around the whole thing, right? So here we know that we have our three finders. We're assuming that they're like axis aligned right now. That's not necessarily like true, but it is for our case for the time being. And based off of like our expected width of the finder, we can kind of like decide what the grid should look like. And so that's working okay for now. From there, we can look at these purple sections. These are called like the format codes, I think. And so they're duplicated. There's one horizontal one and one vertical one. And this tells you stuff like there's like a mask that has to be applied to the data. So if we look at QR code Wikipedia, oh, it's actually up in here. Let's see, somewhere in here, it'll show us the masking patterns. Here. So depending on like what we read from the format code, we apply these masks to our data, and these are just to make sure that like your QR code stays semi-high frequency, right? You can imagine that if you wrote only zeros for your entire QR code, you would just end up like with a white blob, and your parser would kind of like fall over. So these patterns that you can apply to say like, okay, let's keep the high frequency, and then we'll like undo that after we read it. So we read the mask, go to the purple section, we apply it, and then we walk the data according to this like kind of zigzaggy pattern. So it's kind of hard to see here because it's just like numbers on the screen. So maybe we'll look up QR code zag. And we can see here. So the walking order is kind of like this. You kind of like start in the bottom right and you go zigzag, all the way to the top. You hit something, you turn around, and you zigzag back down. You hit something, you turn around, you zigzag back up. You might see like an alignment pattern, so you skip over that, and then you keep zigzagging. There's kind of like some like weird edge cases here where like your alignment pattern doesn't really necessarily cover an entire like 2-block wide thing. So here you might do something where you like skip, you get like vertical bytes directly or bits directly in a row without having to do the zigzag pattern. And then there's also a special rule around these like timing patterns where you don't follow the normal zigzag pattern as you skip, you just jump over them. And so applying all of those rules, we have these like orange data bits. And if I actually look at what our QR code parser does, he says, hello world. He gets the data back out. Wonderful. There's like some like intricacies here. Like there's like different encoding. So these first 4 bits will say like, hey, treat these things as if they're just like normal bytes. But there's also other modes like, oh, please treat these things like they're only numbers. And that allows them to like pack things a little differently, a little more efficiently, I think. Not really sure. Okay, great. So that's where we're at right now. We can parse a QR code, a singular QR code. And yesterday I was kind of trying off stream, trying like some more complex ones. So if we go here and we run QR code decoder on this guy, and I refresh, he fails, and we can look at this guy, and we can see pretty clearly what's happening here, is as we walk this like timing pattern, we start to get like a little shifted from like the real timing pattern. And that's because our grid size is only determined by the size of the finder, right? So we look at this guy and we say like, well, we expect this guy to be 1, 2, 3, 4, 5, 6, 7 wide, and so we'll just like infer what the grid size is based off that. But when you have such like a large thing, then all of a sudden any small error on this finder thing results in your grid just being like totally out of whack. So plan for today. I think what makes sense is there already are these like sections of the QR code that are supposed to just be alternating black and white. And so I think what we can do is to bypass this problem is we should just be able to like walk this section and find how many times it goes back and forth. From there, we should be able to extract a more reasonable grid size from that. And then we can do that both horizontally and vertically. And then this parser will definitely fall over because we don't look for these alignment patterns at all. So these guys are supposed to be skipped. We don't know they exist right now. So we're going to have to do something about that. And actually, I want to look at it a little bit more. So these are supposed to be black, white, black. Got it. So the hope is if we do both of those things, we should be able to decode this QR code. That's what I'm hoping. But who fucking knows, right? We're going to hit problems and we're going to tackle them as we go. But I think there's a pretty clear first step here, which is try to figure out how to parse these timing patterns correctly. Okay, so what I'm thinking. I guess I haven't really thought too much about this. I've only like kind of briefly considered it in my head. And it's like pretty clearly we should be able to walk horizontally across this thing. And there must be some way where we can say, hey, we were looking at white pixels, now we're looking at black pixels. That's weird. Increment count by 1. And I don't think that there's anything we need to worry about like blurriness or contrast or anything. I think we can just say that if we see a large change in value, we'll just increment by 1. Now, I guess you could say, well, what if there's like some blurring like between the lines? Could you like, if you have like 2 pixels of gradient, could you double count? I guess there's a risk there, especially if the gradient isn't like linear. But for now, let's just try. We'll basically just try thresholding on 128. Like, so for pixel values between 0 and 255, 128 is like in the middle-ish. I don't know if 120, I guess it's 127 or 128 because there's an even number of things. But anyways, we'll just threshold. And I think later we can maybe tackle the problem of like artifacts by doing some sort of like blurring / sharpen, like a blur and sharpen with like image filters. But I'll have to think about that more. Like when we get into the real world of like sensor noise and stuff, this will be harder. But for now, let's just work in our perfect world where we can kind of like make assumptions about our data. Oh yeah, I think that makes sense. So on initialization of our QR code thing. Sorry, there's a lot of code in here. QR code, here we go. So right now we say, let's find the finder patterns. That's working okay for this particular case. Then we say, hey, here is a rectangle that represents our QR code, but we haven't actually figured out what that is yet. Then we find the corners of our finders and set that to be the border of the QR code. That seems reasonable to me. And then here's probably where we run into problems, is we say the element width is related to the size of each finder. We average the sizes of each finder, I guess is what we're doing. So we say, hey, this one has a width, this one has a width, and this one has a width, and just like fucking take the average of the 3, and then divide it by how wide it should be, and then you should have your like block size. And this is just not what we want to do anymore. Instead, probably we want to still find the corners of the QR code, because from there we can kind of derive where these time patterns are. I guess like, yeah, I think that makes sense. Then we can take like the height of our finder and use that to find where the bottom left corner of this like, yeah, if we take like the height and width of our finder, we are at the bottom left corner of this timing pattern start. And so then we just kind of, we have like a good guess for what the element size should be. So at this point, if we were to just like divide, like try to get into the center of this line, I think that would be fine, right? Because the errors only start stacking up as we get into like large Y values or large X values. So here we're at like a pretty low Y value, so we should be able to reliably get into the fucking center. I think, right? That makes sense to me. And then from there we can just start walking sideways. So let's say LM width here is going to come down here. Boom. We have our QR rectangle And here we just took maximums and minimums. Okay, sure. So at this point, it should be valid. And so now we can say timing y position is equal to something. I guess it is. I guess here we still want to average out the finder size. I think that makes sense. So here we'll do this. Finder width and finder height is like this. And then we can say that the timing row is equal to what? The QR rectangle top, right? So that's here. Plus, I guess maybe we will make an estimated element size. Out of curiosity, is the animation playing live relevant to the project, or is it just something nice to have there? Oh, okay, so this has been there since I started streaming. It was the first thing I worked on because I saw on TikTok children like watching videos where there's a guy talking and a like guy running on a little train playing a little video game, or with Family Guy clips, you know? And so to keep engagement up, we got to keep you guys interested, give you something to look at. I wrote this little thing and played on the side. It's fucking stupid, I know. But I do catch myself, I watch my VODs back, and I do catch myself looking at it. And I think that's good in some way, right? Like, because coding's fucking boring. Right? It's just boring. So if you have something to like keep you occupied at the same time, it like can maybe help you stick around. Ooga booga brain nerves firing ooga booga. Exactly. Okay. So let's start with like an estimated LM height. Next step is purchasing the rights to play Family Guy clips under the code. I doubt anybody who's doing those is purchasing Family Guy rights, right? They're just kind of like hoping for the fucking best. I do at some point kind of want to like up the ante on that thing, but that's like, I don't really know in what way. It would be kind of fun to like, it's getting kind of boring, right? If we want to keep engagement up, we have to keep it fresh, you know? But I don't know if I'll ever actually get there. Okay, estimated element height is the finder height over the finder num elements. Great. And the estimated element width. I guess we don't need the estimated element width yet. We will eventually, but we'll start with just looking at the first timing row. So, estimated element height is that. And then we can say that the timing row center is going to be equal to the top of the QR code plus finder num elements times estimated element height minus half of the height. I think that makes sense. This guy, what is this guy? Probably a float. And so here we can probably just floor that or seal it, like round, I guess, makes sense. So const timing row, I'll call this timing row center F for float. Then we'll say const timing row center is equal to, I guess we'll just fucking round it. Timing row center F. And from here, I guess we have to then say int from float to get it into an integer, and then we'll call this a usize. Timing row center pixel. Okay, so now we can just say that we go for probably a while loop makes more sense here. And I guess we start with some like tracker for our left position. So const timing x pause is going to start at the QR rect left side plus the finder num elements times the estimated width. Yes, I think, which we don't have yet. I guess like for anything that we're doing right now, The height and width will probably end up being the same, but it's kind of nice to split them conceptually. Okay. So this should put us right here. Right here-ish. And I guess then we can just start walking. So we have a reference to the image here, which is good. And we can just say, while timing x pause is less than qr rect right, probably minus the finder width, minus estimated lm width over 2. Right, I'm trying to basically say while we are less than here. Maybe here? Maybe we want to consider this extra piece as well. We should also probably start in the X center. So maybe we go from this section, this here. Maybe we start in the finder and end in the finder. And that will give us 2 extra flips to work with. So this is going to be plus finder, and here we just subtract estimated lm width over 2.0 like this. And while this is less than, we'll just say that this is like timing iter end or something is going to be this guy, because I think that then it won't recompute it every time. Maybe it wouldn't anyways, but you never know. You never know. I don't really know how good Zig is at that type of optimization. I guess it's using LLVM under the hood, which I imagine is doing most of the heavy lifting. But it is something that I would like to look into at some point. I don't know if it's worth looking into, but my curiosity is like a little bit tickled. Not enough to actually do it, just enough to think about it and then not know. Okay. So timing xpause has to be mutable. And I guess we just say is light pixel, and we pass in the pixel value, right? So I guess we also have to say var is light. Yes. And he will start as this lookup, but given x and y position. So we have to look it up in the image. So we say image dot what? Get? We do have a get for just x and y position, so let's do that. Timing x pause and timing y pause, which we don't have defined right now. Oh, we do. Timing row center px. Okay. And now we just keep doing that. So we say timing x pause plus equals 1, and we call is light. I guess we'll call this last is light. This is light. Yep. And then I guess we just say if is light is not equal to last is light, num lms plus equals 1. Yeah. Sure. And then we have to set last is light is equal to is light. Do that unconditionally or conditionally, doesn't really matter. Arguably, one of them could end up being easier to optimize, but who fucking cares? Sure. And then we can just check the count. So I guess num lms should start as finder width times 2. Right? Because like if we're trying to figure out how many elements are in like this entire grid, and we start here, we're going to increment for each of these items in the timing row, but we also have to add in like the fatness from the side. So I guess it's like it starts as the finder, it's num finder elements times 2 minus 2, because we are counting the flip that goes to the edge of the finder in this iteration. I guess we don't actually have to. Yeah, fine, it's fine. No. I think that we should start, instead of going inside, we'll start. It doesn't fucking matter. It doesn't fucking matter. We'll just do it the way it is for now. Fix me. Should we start iterating outside the finder to make this prettier? And save 2 element iterations. I think it doesn't fucking matter. It doesn't fucking matter, but it could. You know? Okay. So now we should be able to say that we have some amount of elements, and we can just divide that by the width. And this is probably float from int here. And elem height for now, I'm just going to keep as estimated elem height, and we'll come back to it. This should be as f32. Yup. And I guess maybe we'll pull this out here. So const elem width is equal to this. Yup. And here we'll just use estimated again. Actually, I'm kind of worried about that. I'm going to say const elem height is equal to estimated. And then when it changes in the future, I don't have to worry about forgetting to update these guys down here. Okay. Let's see what happens. We don't compile. Obviously. So timing xpos. This we need to turn into a usize as well. So here we're going to do something like int from float, round, and then we should be good. Expected type f32, found usize, another one. So timing iter end, we also are going to give the same treatment. Okay. So we are panicking, which means that our SVG never finishes getting written, which is fucking annoying. So where is this coming from? This is coming from grid height equals int from float round, blah, blah, blah. Hello, I think finder width and finder height are always 0. That's a really good point. Yeah, so this should be QR rect, or rect height. And this should be height. This should be width. Good eye. Okay, so when I watch these streams, there's no way I'm catching minor details like that. Are you like staring and thinking? I guess you must just be like looking and thinking about the code from the glimpses that you get from it being on my screen, which seems crazy to me. That seems like insane. Because it's just like I'm moving like at the rate that I'm thinking, and so it just means that you have to be moving faster than that. Which I guess is just, am I just saying I think it's crazy that someone's smarter than me? That's insane. I shouldn't be saying that. So I guess that is just what people do. But when I watch this stuff, I'm just like kind of like sitting there, you know? I'm just like la 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 in my head and like listening to the guy talking. I'm always so impressed when you guys found my bugs for me. It's so sick. Is light ROI at 42 image is crashing. So he's kind of saying for start X to start end, integer overflow. Where is this coming from? Okay, I guess we just have to GDB because I don't really understand what that is complaining about. So we'll just kind of GDB args this run backtrace. I saw it a few minutes ago. I was waiting to mention it if you didn't catch it. Ah, nice. P start X, P end X. Okay, so the overflow is coming from start greater than end. So what is happening there? So this is coming from a backtrace of is light ROI from inspect timing on main zig 172. I guess let's maybe print out what we get here. I must just be fucking something up. Maybe instead of printing, we can debug. What am I looking for? List. Can I just like info locals? There we go. Finder width and height, 57. Number of elements, 116. Elem width. What? This is fucked up. I have this. This is fucking backwards. I'm just a fucking dumbass. This would be QR rect width over the number of elements, not elements over width. Okay, let's try that. zig, build, and run, please. Okay. I misspelled width, as always. I've made that typo probably like 1,000 times in the past like couple months. And here this feels worse. It's too big. So either our count is wrong or we're dividing by the wrong thing. Like either we're like, as we iterate, we're flipping too many times or flipping too few times. I think it's more likely that our initializer here is wrong. Let's just take out that -2 just kind of at random to see. Nope. Okay. Let's actually use our heads. Let's use our heads a little bit. So we can do the same GDB thing. Oops. That breakpoint is no longer set. Fuck off. Let's do a little tricksy. So we'll say edit run.gdb, and here we can say file is /zig out bin QR decoder. And then we'll set a breakpoint at wherever the fuck we want to. And then hit run with input of this output test. And then when we do this, we can just say gdb-x run gdb. There we go. Info locals. Let's take a lookie. Element width 8.11. Number of elements 118. Is there... Do I just have to fucking count? Is that what we have to do here in order to validate? I guess we could run this on a smaller one where I don't have to count. And maybe that's better. Is there like an untitled? I think it's untitled GIF. Yeah, let's do that. Info locals. So here we're getting number elements of 22, and this should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So we're off by 1. There must be something wrong. Like this iteration, I just must not have done the math right. QRect right minus finder width plus this. Off by 1 errors. Love it. I don't even understand why, though. That's kind of bothering me. So we start at the left side plus the number of elements times this made width minus element width over 2, which I'm pretty sure puts me fucking here. Right fucking right here. And then we end at right minus the finder width plus the estimated width over 2, which puts us right in here. And then we round. And then our number of elements starts at 7. Oh, because since we're starting inside, we only have to adjust once because 1, 2, yeah. It's something about like the number of boundaries crossed when we're starting from here and here is only 1 less than the 2 finders combined. I think that makes sense. I like reverse engineering the answer from like the data. You know when you're like, you write a bug and then you look at the data and then you just like make up an answer to fit the data. You're not actually like figuring out the correct answer because you can easily gaslight yourself into thinking that whatever the data says is reasonable. It's so easy to do that to yourself. So that's what I'm doing right now. Okay, so what do we get here? Oh, okay. So I think that looks okay. Right? That like horizontal timing, it's fitting pretty fucking nicely. Now what's kind of interesting here is that the boxes for the finders aren't perfectly lining up anymore, but that kind of makes sense because the finder boxes are based off of like an incorrect guess. But these red boxes are fitting pretty damn well. So I think I'm okay with it. Let's kind of factor this out into some function because we want to do this both horizontally and vertically. And so how do we want to handle that? What is going to be different from the horizontal and vertical versions of this? The timing row, these offsets are actually going to be the same for both the horizontal and vertical version. They're just going to be kind of like flipped around which axis we're working on. But I think everything else kind of stays the same. So I wonder if we could just replace this image getter function here with these two values inverted for the y-axis, and then that might just kind of work out. So let's try that. We will say we have like this function that's like find lm size, and he's going to take in some shit and return a float 32. I don't know what he's going to take in yet, but we'll find out by just copy pasting this whole thing, and it'll become obvious from the compile errors. So here we are going to take in, I guess we'll calculate the starting position first, and the timing iter end. I'll rename these in a second, but for now let's just do it with the way it is. So we'll take in the start and end positions and the estimated size. Oh, we don't need the estimated size, actually. I don't think that's being used anywhere in here. Okay. And we take in a function to get pixel. Get pix val is going to be some function that takes in two u sizes and returns a u8. And I think I have to say that this is a function pointer. Like this. And so this is going to say get pix val. And actually it's only going to take in one u size. That's the difference here, is we're only going to take in one. So here we're going to say timing x pause. We're going to rename this later, so it's fine. Get pix val timing x pause. Okay. And I think everything else here just works. Elm width is the we also have to pass in the like, I guess we won't call this find elm size, we'll call this find. No, we will. Find elm size, and we're just gonna pass in the total size, I guess we'll call it as an F32. And then that gets rid of this. And then we can return this like this. Okay. And so now what? We delete kind of all of this stuff. Oh, well, let's not delete anything yet. Let's get -u, get commit, get checkout, branch, whip, get commit -m, checkpoint. We'll fix this later. But we need something so that when I delete this stuff and it doesn't work, I can go back without getting angry. So find lm size based off of our starting xpos, our end xpos, and our function, which we have to make. So it's going to be like const. I guess we could take in this function at compile time. Today, no, I'm going to hate myself for this. Well, I will. Don't you worry. I hate myself all the fucking time. You can't stop me. But that comes out a lot worse than it is. I hate the past version of me for doing shitty things in code. Not like, I'm depressed, oh no. Let's just, that's gonna be left uncommented on. I'm just trying to clarify what I was trying to say. Yeah, there we go. So we'll call this get timing, get x timing val. Yeah. And in this language, there's no way to like just kind of make a function on the fly, but you can do this kind of trick where you make a struct, and inside the struct you make a function, like this, and then you can return the function here. Little tricky. And so this get function is going to call what? He's going to say, he's going to take an usize and return a u8. And he's going to return image. Oh, fuck. He has to take in the image, huh? He does. He does. So he's going to say image get val. Oh, fuck me. He has a lot of stuff that he has to store inside him. Right? And this language doesn't support like lambdas. So this being a like function doesn't make sense. This has to be a struct. So we need to have like a is that like an inline function? Yeah, it is. So we actually have to have like x struct timing x image timing pixel getter. We're gonna rename that later, maybe. I don't want to name it that. I think the function, the param comes comp time if you remove the star const prefix. Yeah, it does. But the problem is that I need to like bind elements to it, right? Like I'm trying to actually do something that's more like a closure or a lambda or whatever the fuck you want to call them. But this language doesn't support those. So instead I have to make a structure that takes in the things that I care about. I think. I don't know, we'll see. Naming is harder than off by one errors. Yeah, it's not simple. I found myself spending a lot of time after stream, like just renaming stuff. Like going from the like we prototyped something to something that's like elegant and pretty can take like quite a bit of time. But I like the idea of just kind of plowing through the bullshit at first, just so that you can like really flesh out the problem before spending time on stuff that might not matter later. Okay, so we're going to wait a second. No, I don't need to store anything here. I'm an idiot. Which is why it was good that I did this. So here we're just going to say oh no, we do. I'm wrong again. We need the timing row center pix. I was going to say that we could just use like a constant for how much how far in we are. I guess we could look for like estimated element size. Sorry, I'm kind of like jumbling. Like, thoughts are not coming out cleanly right now. Okay, so what I was thinking is, if you think of this guy in terms of grid, the x and y positions are kind of like fixed here at position 0, 1, 2, 3, 4, 5, 6, right? But where they are in like pixel space is dependent on the width and the height of the image. So you do have to like cache something there. So I think I am just gonna like cache the calculated thing here. Image timing pixel getter. Yeah. And then if we were to say function get, who is going to take in just the value now, and he's going to return a U8. He's going to return self self.image get and val and timing row center pix. I have the height boxes wrong. Yeah. These ones? Yeah, we're getting there. Okay. So this is going to be image timing x pixel getter. Yeah. And then we can construct this thing, so we can say that we want I don't fucking know, man. Maybe we're gonna have like an init function on this guy too. And what does he take in? Like, what are these calculations based off of? I guess we're just gonna slap this in here and kind of see what happens. So timing row center px is f32 is equal to timing row center px. And like now that I'm kind of doing this, it's kind of feeling like this structure should kind of be more. Like it's almost turning into like this thing being an iterator that returns pixel values. and then the function that calculates like the estimated size could like walk this thing as a pixel iterator. Yeah, I kind of like that. Timing x pixel iter. That feels nicer. And so instead of this get function, we'll just have like a next that takes in self. And you're just going to return a U8. But not a full U8, an optional U8. We don't know. And that's just going to be something like... I guess here we're going to store our x position. And then we're just going to return if... And I guess we store the end as well. Yeah, that's feeling okay. I don't see anything crazy there. So here we just say timing x pause equal to timing x pause. And timing iter end is equal to timing iter end. Easy peasy. And then here we just return self image get self timing x pause self timing row center px. This is a return, and we need a way to like exit the loop. So we say if we are too far in, right, like this, we return null, return null, and then that also means that we must have to increment the time position. So we just kind of throw a little self timing x pause plus equals 1. Boom. All right. Which means that this guy now is going to take in just some sort of iterator. And he's going to call it next for the first thing. Yeah, sure. And then he's going to say while it next val, pass in the val here. Boom. And then the rest of this, I think, just comes for free. I think. Something is bugged. There's some missing bracket somewhere. So this is at 75. No. Oh, it's probably that I started... Like, this is fucked up, maybe? Yeah, this is just not closed. So here we're going to say const... we're going to have some, like, variable that's like x timing iter is equal to... image timing x pixel iterator initialized. And then we're going to say that the element is find element size with a mutable reference to x timing iter like this. Okay, it's still mad at line 75. So what doesn't it like here? Oh, there's an extra bracket in here. I'm just... Hi. All right. Total size. We lost total size here. So total size is going to be a F32, I guess. And here, find element size. Did I spell it wrong? Find element size. Elemu. And here we're gonna have to pass in QR rect width like this. Okay. This stuff goes away. How did I lose? Oh, hold on. This init function is probably missing a bunch of like a required input here. So we need the QR rect as well as the estimated LM width as a at float and the estimated LM height as a float. Hey, what's up? Finder width as well. Okay. Sure. And the image. All right. So here we pass in, what was it? Image, QR rect, estimated LM width, estimated LM height. Was that the right order? QR rect, width, height, and the finder width. All right. I think that's fine. Let's see if that still does the right thing. Nope, not yet. So 792, what's going on here? Oh, we forgot to convert this first pixel value. Forgot to convert this to something, a Boolean, based off of its lightness. Okay, so now if I refresh this, it does look like our X values are good, and so now we can just kind of create like a similar Y iterator. I do believe QR code decoding is easy enough to code, but how do you deal with skewed images? We're gonna get there eventually, maybe. I mean, that's my plan at least. Kind of what I'm thinking right now is that like any QR code is going to be some quad, and in that quad, we're going to be able to find the finder positions, right? They might be kind of this way. And from here, you probably can draw some sort of like 2 lines, and from there you can kind of maybe do something like iterate along this line and this line, and as you like get farther away, like you're gonna have to do some sort of like stretching of this. I don't know, I haven't really thought about it too hard, but that's kind of what I'm thinking right now. We'll see though, because we haven't really got there yet. Right now we're just focusing on getting a perfect QR code working, and that's not even good enough yet, so you know. We need to take it as it comes. Okay, so we'll just do the same thing for Y here, and I don't really know how similar this is going to be yet, but we'll find out. So he's going to be like this, timing call, center pix, Y pause, timing iter end, that's going to be the same. This is going to be based off of the left edge instead of the top. And this is going to be based off the estimated width, then the height, then the... yeah, both of these are width now. This is the same. This is going to be height. Anywhere we say width is going to be height. Here, so this is estimated LM height here. Oopsies. And this we have to be careful about. So this is going to be related to the top, because this is a Y position now. And this is also going to be relative to the bottom. And this is going to be finder height here instead of finder width. And this becomes timing Y position. This stuff gets inverted down here. So here we're looking at the Y position. This is Y as well. This is Y as well. And I wonder if that's like similar enough. There's definitely like something common in here. I just don't want to worry about it right now, but there's some sort of like fix me, extract commonality with X pixel iter. Like there's something in there, I just don't know what it is right now. So we're gonna do the same thing here where we construct a Y timing iterator that comes from Y, and he's gonna say these are all the same but here, but now he's gonna pass in finder height instead of the finder width. Then we are going to say LM height comes from the Y timing iterator and QR rect height. Okay, and now let's see, maybe that actually kind of works. I don't really know what it was doing there, but it felt like an infinite loop. So let's just go into main and kind of try to like exit out early here, just so that we like get somewhere. That is taking long. I think that I'm just assuming there's an infinite loop in there. If true, return, and we're gonna do this in main as well. Here. Okay. Oops, no timing patterns there. I must have fucked up something. It's here somewhere. Horizontal timing, it's here. This is where I want to return early. Okay. So that's a good sign. It looks like our vertical and horizontal timings are now looking a lot better. That's really good. That's really good. So I guess we can say adjust time, use timing patterns to adjust our grid size. That's like kind of maybe done. I guess it's going to depend on how fucked this stuff is. So Draw format boxes. Let's see if that's working. Oops. So we also have these like nice little purple boxes over here, which is good. That's also what we want. Great stuff. And it's probably this stuff that's failing, if I would have to guess. Yeah, so let's kind of just cap the iteration here. If I is greater than like 1,000, let's just kind of return here. Oh, yeah, that should work. That should work. So let's give it a sec. He did return, and let's just kind of see what the fuck did he do here. Oh, is it possible that there's just a fuck ton of data in here? That seems possible. It's actually really hard to tell what the fuck is going on here because our font size is kind of fixed, which is kind of funny. So can we maybe get in here and draw text? I guess our font size should be like somewhat relative to our image size, which we kind of already did. So I'm surprised that this is falling over as hard as it is. Let's just make our font size smaller and see what fucking happens. Okay, that's definitely smaller, but it's also fucking illegible, which is kind of funny. So let's look at our stroke width. Maybe also order of magnitude reduce the stroke width. Okay, so we're zigging, we're zagging. We come up to the top. We have 214, 215, 216, 217. Great, great. Okay. Let's kind of just increase this then. Our main. Let's kind of just allow it to go to something way bigger. Where were we? Here. 1,000 is shockingly not enough. So how far in do we get? So this needs to go up to like 10,000? Like an order of magnitude higher? Holy fuck. I like your stream, high code quality, good chatting. Oh, thanks, man. Appreciate it. Oopsies, where'd it go? So it could just be, I bet you we're just spending a lot of time in SVG writing. I'm kind of curious now. Zig, build. First of all, let's try doing a D. There's like a way to like specify that we want to go faster. De-optimize. De-optimize. Optimize equals release safe, maybe. Let's just see if that's like incredibly faster. And if it's not, then it might be worthwhile now to just take a look at performance, because this is like ridiculously slow. Whatever we're doing, somewhere we're doing something fucking stupid. Because it should not be this slow. I actually don't know if this. I think that the release builds are very slow. Or slow to build, but fast to run, if I remember correctly. So let's just kind of like time this. Like, what the fuck is it doing? What the fuck are we doing? Let's look at top now as well. We are just maxing CPU for a long fucking time. 6 seconds. That's ridiculous. So I guess I'm I like that so I don't know what the fuck causes this, but when I stream on Wayland, like capturing a window sometimes just takes 100% of a core. Sometimes. But sometimes it doesn't. And so sometimes what I'll do is I'll like watch top and I'll start OBS and stop it just like 10 times in a row until I like roll the dice right. But also like I guess I don't know. Yeah, it really is taking like an actual core because my idle time is there's not like a core pinned with 0 idle. So it could be that like we're stuck doing some like what does R mean in here again? I have to remember. Top state codes. So fucking stupid. Like what did I expect? Right? What did I fucking expect? Linux top state codes. What do all the values Yeah, so Aura does mean running. So it's not like blocked on IO or anything. Like sometimes you see stuff like that's like cranking out CPU in D state. So I don't know what the fuck it's doing, but whatever it's doing is fucking stupid. But you know, as it is, stream on Windows. But dude, you think I have Windows? That's a crazy. You're assuming a lot out of me right now. I actually did used to have a Windows install specifically to play Fortnite. I played so much fucking Fortnite, man. What a fun fucking game. But eventually I stopped wanting to like manage I have like a 1 terabyte drive, and I just like stopped wanting to like manage space. I'm like, I could actually have a lot of other drives as well, but they're like slow and falling over, and I'm just like, oh, it's just too much work. And then like booting into Windows, like I have like $1,000 of CPU, or not of CPU, of like computer parts just sitting on the floor in the corner, because I bought all of these parts to build a server, because I'm running all these services on my machine. I hate rebooting and then having like my TV tracker go down. It's like fucking annoying, or like not being able to watch TV while playing video games. It's just like annoying. So I bought the server, and then the motherboard and the CPU, like the motherboard has to be upgraded to run with the CPU I bought, but I need a CPU to put into the motherboard to upgrade the BIOS. And so it's just been like sitting there. So all of that to say, it's like, if the server worked, then I would install Windows and play video games. But instead, we're in this state where I'm too lazy to fix the computer. I'm just wasting money. It's just been sitting on the ground for like a year, maybe 2 years at this point. And we just make our whole lives shittier as a result. How does that sound? Just fuck up our lives a little bit, you know? You have these easily fixable problems, and instead of fixing them, I also have this monitor on the right side of my screen, on the right side of my desk, that's just off all the time, because like I don't have the right cable. And it's just like, man, my life would be so much better if I used that third monitor, but instead I just sit here every day being like, man, it would be nice if that thing turned on. Yeah, you know, those things happen sometimes. What was I doing? I was wanting to know why the fuck this is so slow. So let's maybe do a little bit of Linux packages latest perfing. Let's just kind of see where we're spending all our time. Let's see where we're spending all our time. So we'll look at like we'll say that we're at 57 minutes and 30 seconds, and performance tracking. What the fuck? So we can say like do a little / perf record -d call graph dwarf. I think that gives me everything we need. And maybe we'll limit the iterations, because 10,000 is like way too many. Like we don't really need that level of precision. So let's kind of like drop it down to like 500 or something, because we kind of just want to see approximately where that's going. So let's do a Zig build. I don't really want to optimize. I kind of want to just run in debug mode. I know benchmarking in debug mode is like a little bit fucking stupid, but on the other hand, I'm running in debug mode most of the time because it's faster to build, so getting like the performance metrics on that seems kind of useful in some way. Perf record -d G for call graph. Which type of call graph I want is a dwarf. I don't really know why. I just know that I have to type that or else it doesn't do what I want. And then let's just kind of run it, see what happens. Perf script test perf. Then we can do like Firefox. Let's look at our little profiler. Load a profiler. Load a profile. Load a profile from QR decoder. Nice. Test perf. Here we go. All right, where are we at? Oh, that's pretty funny. It's actually, that's so funny. So all of the fucking time in the program, I guess not all of it, but a fucking big chunk is spent in allocating memory in order to print the number of which iteration we're on. That's so funny. It actually has nothing to do with anything that you would ever guess. It's this line here. So here we say like, hey, I want to write a number of this like index that we're on. I want to write that into a buffer, and our SVG renderer only supports rendering text, So we do like a little buffer print here, and we're using this general purpose allocator. And as a debugging thing, I was like, hey, could you keep track of like the entire fucking stack for every single allocation? And this is fucking slow. It has to walk the whole stack. That's not quick. And so I guess if we just do a little bit of something here where we say, how long have you been programming in Zig? Like a couple weeks, I guess. I think I did maybe, well, we can find this out. If we look at github.com, Spheroforia Zig lib. This first commit was 2 weeks ago. Yeah, so about 2 weeks. 2 weeks. Can't you just stack allocate instead? Yeah, I could have, but I was like, I don't want to think about it. So, what we'll do instead, insane progress. I mean, to be fair, it's nothing crazy, right? Like, once you've done a few languages, you've kind of done them all, right? Like, the syntax, like the differences between like Python, Rust, C, C++, C Sharp, Java, they're like, there's nothing, it's not JavaScript. It's minimal, right? Like, they're all imperative programming languages. There's like slightly different, like you have to think about memory allocation a little bit different in all of them. But once you've done a few, the next ones aren't that crazy. I imagine real life languages are like this too, right? Where you learn like 3 Latin languages, probably picking up the 4th is easier. But that being said, I fucking suck at all languages, including the one I speak natively. So I don't actually know. I've never learned Zig, but I can understand 99% of the code. Yeah, exactly. It's nothing crazy. Like, I did find, like, sometimes you pick up a new language and you're like, holy shit, this is like a mindfuck. Like, when I picked up Rust, it changed the way I wrote all of their code, like, forever, which is, like, very nice. I like that because it's, like, it was forcing these constraints on me that made me think about my problems differently. And then, like, going back to C++, it's like, oh, instead of making, like, one giant struct with a mutex on it, what if I make one struct for each thread and then I, like, pass the data between them? Like, stuff like that is, like, really different. But, like, Zig, there's nothing in here that's different than what I would do in C or C++. Really. Like, the only thing is, like, comp time generation is, like, kind of nice. Where in C, you would be using macros. In C++, you would just, like, shoot yourself. But, yeah, it's nothing crazy. Nothing crazy. This is why, like, when I was doing interviews for when I was, like, working a job like a normal human, I would always argue that, like, I don't give a shit about the interviewee's, like, language, and people always seem to put, like, a lot of focus on that, and I never really understood why. Because it seems like once you've got a couple down, like, you know, if the guy's like, I work in C, and so he, like, takes a stood string by value instead of by reference because he doesn't really understand. It's like, but he does everything else right. It's like, who fucking cares, right? Like, I don't give a shit. But, like, I had people I was interviewing with would be like, what the fuck? You didn't write const reference. I'm like, I don't know, man. Like, it's just he'll learn that later. But I don't know. That might just be like a huge bias towards myself, right? I'm like, oh, I can pick up a language. It's not a big deal. But maybe some people struggle more with it, and I shouldn't be saying, like, it's easy. Like, I don't know. Okay. So what we were doing, we were fixing this allocation. We don't need to allocate here. We can just allocate a 5-digit buffer. So how do you do this? You say, like, I want a 5-element U8 buffer that is undefined. So I guess I do this. Yeah. And then here, I write to that buffer, so I do a little buff print here instead. And I can append a capital Z to get it null terminated, which I don't think I need here. And probably here I pass in the buffer that I'm writing to. So this is buff here. Probably I have to put ampersand here to coerce it into a slice. And here he's probably going to return a slice based off of that. Yeah, nice. And then probably here I just say if I is greater than 9999, 9, we crash. Oh, I guess buffprint is actually going to do that check for me, which is pretty fucking sick. Because he knows the size of the thing he's running into. Does this return failure if it's not big enough. Yeah, because he's going to get a writer, and that writer will probably fail. Fixed buffer stream returns fixed buffer stream writer. Presumably this write thing fails if the position is... Yeah, that's sick. Okay, sick. I kind of expected... I'm so used to like the C sprintf where you really have to like pre-check this shit, but that's pretty cool. I like that. I like that a lot. Okay. Does that mean that this guy doesn't need an allocator? No, he must still use it somewhere. Okay. So I think nothing else changed there. And let's just see if that fixes it. Yeah, okay, so foreground. Let's cap this back at like 10,000. That's still quick. 10,000. We don't know how much time is spent building there versus actually running, so yeah, that's not bad at all. That's fine. So that's pretty funny where you just have like one stupid shit and it eats all the time. It's funny though, actually rendering this SVG in Firefox is really fucking slow because there's so many elements, but it's fine, we'll get there. And if I zoom in here, the text is good. Okay, cool. Cool, so let's cap this at 100,000, maybe. Yeah, order of magnitude, that's fine. I don't think that it's gonna be a problem. Yeah, it looks like it's fine. And it does look like we made it to the end. Oh my god. Oh my god, it's so slow. It looks like we successfully jumped the timing row here as well. 6-2, 6-3. Whoa. 6-6-2, 6-6-3, 6-6-4. What's happening here? Oh, I see. We're zigzagging up. We come here, 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 and then jump across. Yeah, that's right. Okay, cool. And we get up to value 13,263. And so this cap that we've put on is actually doing nothing. Which means that we can probably remove this return true. And we can actually try to like run this thing and see where it falls over next. So here it's printing out absolute fucking trash. Which makes sense to me. Because we haven't filtered out these alignment patterns. So I think that's probably the next thing on the list. Fixing performance bug. And let's work on fixing alignment markers. Okay. So I think that the logic for these like alignment marker finding is going to be much simpler than the original finder finding. Because now we don't have to worry about like working in pixel space, we can work in grid space. And probably we just walk the entire QR code and just fit this pattern to it. Right? That doesn't seem crazy. We walk it like element by element. And we just say, is this a fucking thing? And I guess probably walking just horizontally over the whole thing is fine. We could like reuse our like bit iterator that does like the zigzag pattern. We could do it once with no alignment patterns, looking for alignment patterns, and then do it again. Does that make sense? It saves some code. It means that we don't have to like write like a second iterator. But the idea of just walking left to right, top to bottom doesn't seem that hard. Right? Like, I don't think that we have to skip anything, right? It would get more complicated if we had to worry about, like, the timing patterns creating this alignment marker. But I actually think that I've seen the alignment marker end up inside the timing pattern in some of these examples, actually, now that I think about it. I remember thinking, that's fucking weird. Right? Like, if we look, here, this is the timing row, but there's an alignment marker inside the timing row. Which kind of indicates to me that we shouldn't be using the same iterator. We should just be, let's just walk the whole fucking image. Yeah, that's fine to me. Okay. Okay. So let's, I guess, make an alignment finder. And I think we'll follow the same pattern of making an iterator of some form. I think that makes sense. So we can do something like we have like alignment finder. and he's going to take in some things. At this point, like the QR code is not going to be fully constructed, so we're not going to use him, but we could pull in like some of the aspects of him that are interesting to us. Specifically, the region of interest is almost certainly related here, although I guess maybe we just use that to find the start and end. So certainly the element width and element height and grid width and grid height are going to be important. This function of there's a function in here somewhere that goes from like XY index on the grid to rectangle, which is kind of nice. This uses what? Element width, element height, region of interest, top and bottom. So maybe what we'll do is we'll pull this function out. Put it over here. And he's just going to take in a rectangle here instead of like the QR code. And then here we have ROI. Here we have ROI. Oh, and I guess we have LM width as a float and LM height as a float, which makes this kind of like a nasty function, but it's fine. It's fine. Okay. So now we can call, oh, if we use the same function name, we get in this like kind of fucked up state where there's like name collision. So I think that here you have to do something like const QR is equal to this, and then we have like our own module that we can reference. And then here we can say on IDX to ROI, we can just return QR IDX to ROI given all of these things. We have our self ROI, self LM width, self LM height X and Y. Let's just double check that. Width, height, X, Y. Rect, width, height, X, Y. Yep, okay. So we just return this here. Boom. Delete. And now when we are in this guy, we can call the same function. So let's start with our like X pause. We're going to store our Y position. And we're going to have the QR ROI. And I guess also the image in here. Yeah. Okay. So every iteration, we might return a rectangle that says, hey, this is a fucking alignment marker. I guess maybe this will, like the rectangle is good for like drawing it on our SVG as like a little debugging thing. But it might also be nice to return the value of it, like the the like coordinate in grid space. So we'll kind of give it an X and Y U size, as well as a region of interest. And then we can return some output. I like that. I think I like that. And I guess we'll say if Y position, I guess we do our iteration at the end because we're using U sizes and we start at 0. So we can't do like pre-increment, which sometimes makes things nicer. So, but at the end, we're just going to say if X pause is greater than or equal to grid width, we set to 0 and our increment the Y pause, which means that we need to take in self here. Of course. Of course. And then here we say if self Y, I guess we don't do anything about Y pause here. At the beginning, we say if Y pause is greater than or equal to the grid height, we return early. Say we are done. No more iteration to do, please. And then here's where the actual work kicks in. So we're going to look at the I guess I'm going to call this QR ROI just to make it like clear. And we're going to have what? We're going to look at a box relative to the entire QR code. And it's a 3x3 box. So I guess our X position and Y positions, are these we have to decide what these mean, right? They could be the top left corner, they could be the bottom right corner, they could be the center. Let's call it center. Doesn't really matter, but no, we'll say top left. And that means that these exit conditions are going to have to be self-grid height minus 3 instead of the grid height. Because if we're iterating 3x3 chunks, all of a sudden it doesn't make sense to go off the edge. Okay, so we're going to do something like for 0 to 3 y offset. For 0 to 3 x offset. We're going to check the value of the thing at that position. So we're going to say like, if this is light, IDX to ROI with the QR, ROI, LM width, the LM height, and the X position, plus the X offset, and the self Y position, plus the Y offset. Yeah, so this will tell us if this like region that we're looking at is light. Yep, let's put a little comma in here, and then try to do a little zig format source. Because fuck this, much better. Restart the language server. And now we just need to check this to see if it matches the box. And the box, we can just probably do some sort of like modulo arithmetic, right? We have 0. So if the Y column, maybe not. So light is going to be X mod 2 or Y mod 2 is 1. No, it's just if X is 1 or Y is 1. Yeah. So const should be light is that the X offset equals 1 or the Y offset equals 1. That should give us this little ring here. And then we can just say, so for any of these guys, I guess we put like an outer loop here. I think you can do this. And then we can just say if is light is not equal to should be light. Can we break? I don't know like the syntax here. Is it outer like this? Zig documentation. There's like loops, break. It's colon. Break colon init. Where does init come from? Labeled break. Break colon block. Block. Okay. So it's break colon outer. Okay. Otherwise, what? Otherwise, if all of these things pass, then it is. So it kind of makes sense to split this into a function instead. Actually, that makes just way more sense. It'll like clean itself up a little bit. So we can say is alignment element self. So at our given position, are we at an alignment thing? Yes, that makes sense to me. So he's going to return a Boolean. And it's just going to be this loop again. Double loop. Dum 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 dum. Eat this guy up, put him over here. Here, we are going to return false. And if we make it to the end of the loop, now all of a sudden we can just return true. Great. And then here we can say if we are an alignment element, we just have to return this thing. Which should just be something. Otherwise, I guess we do all of this in a loop. Yeah. And then here, if we are alignment element, we return the thing. Okay, so his X position and Y position, I guess we will return X pause equal to X pause and Y pause equal to Y pause. What am I doing? Y pause and ROI is equal to top. We have to like do the conversion, which is annoying. So I guess we say IDX to ROI. I think that this will be the easiest way to get what I want. So we call this function with the QR code ROI. And what else is in here? The LM width, the LM height, the X position, and the Y position. And then we just adjust the right and bottom edges. So we say ROI dot bottom plus equals the LM width times 2 to get it to be 3 wide or 3 tall, I guess. This should be LM height. And the LM width should be like this. And then we can just return ROI like this. Okay, so this doesn't actually do anything right now. But we should go into our visualize section here. And maybe what we do is instead of doing this like bit iterator for now, let's just do alignment iterator. So I think this is QR alignment finder. I guess he needs an initializer. Pub function init. And I guess we just take in all of these things. Just kind of annoying, but it is what it is. We will live. Okay, and he's going to return a alignment finder. And then I guess we just return this thing. I had an idea earlier for finding the element width and height. Take the first box width as a guess and loop. Adjust in guess until remainder of guess div total below some threshold. Oh, so you're kind of looking for like a right edge. So you think that the thing should be like 7 wide, and then you check it against the thing that it ends up against. Width as a guess and loop. I think I'm missing something about what you're talking about, like when you say and loop. I don't know what you want to loop over there. Because what we did is we just looped over the what we ended up doing was just looping over the timing iterator, like the timing section. And I think that is what we did, is we used to, in order to like figure out where they were, we used the initial guess from the finder. But I think that you might mean something else. Not sure. All right. So all of these guys get a Vim macro treatment. Put a dot here, yank till the colon, jump to the colon, put an equals, paste, and then delete the end of the line, replace with a comma. Nice. Easy. And then here we just get x pause equals 0, y pos equals 0. All right. So now in our visualizer, we should be able to make this thing. So the ROI comes from our QR. We do have a QR code. QR code ROI. I guess all of these things are just going to be in there. So you know the total width, so loop until the guess remainder total is below threshold. Oh, I see. So you just like keep incrementing finder width, and then at the end you hit the end and you have to like figure it out. I think that like if you were really, really, really wide, I think that wouldn't work if I understand what you're saying correctly. Like I think that there would be still a potential to get like one whole element off. I think. But yeah, I don't know. Is this in the right order? LM width, LM height, grid width, grid height, image. Okay, so this is just going to be each of these guys going to get the macro QR code dot go to. Fuck, I fucked it up. QR code dot go to semicolon, no, full colon, delete end line. Boom. Okay. And var alignment finder is equal to this. Place this. Semicolon. This needs a comma here for it to get the full treatment, I think. And then I think we just say for while alignment finder next, we're going to have some sort of item, and we can just draw a box for the ROI of the alignment finder. What color? What haven't we used yet? Blue, maybe, for a box? I don't think we've used blue boxes yet. Next is not marked pub, so we throw a little pub on this guy. And now he's mad at all sorts of stuff, so 915. He doesn't like self QR ROI here, probably because he wants an ampersand on him. Is light ROI expected 2 arguments found 1? So this is at 889. He expects us to, oh, we need to pass in the image. Okay. Then there's some more ampersand issues. So at QR 890, he wants a little ampersand on this guy. Another one at 889. What is he complaining about now? Expected type const to direct found to direct. Am I high? He expects const rect. Oh, this needs to be a pointer here, I think. Okay. There we go. It feels like we're infinite looping. So let's look at our GDB thing, and I'm just going to delete the breakpoint, and GDB-x run GDB, and then it's going to run for some amount of time. We can just kind of like hit this and kind of see what the fuck is going on here. So this is in our alignment finder, info locals, or p self, I guess. So we are still at just x pos, y pos. Oh, probably because when we find one, we are returning before we increment. Right. So this is why sometimes pre-increment is a little bit easier, is because we don't have to like stash the thing and then return later. Okay, so what do we do here? We have var ret is equal to null, I guess. This is like a question mark output. And then we said, oh, use a defer block. I like that. You're smart. I forgot that you could do that. I like it. I like it a lot. I like it a lot. Ah, that's nice. Woohoo, baby. Wonderful. Oops. Zig build. That's one of the things that like the defer block makes a lot nicer than using destructors. Because if you wanted to do that with a destructor, you would have to like make a new type and it'd be a pain in the ass. Info p self. He's still not adjusting his X and Y position. What is happening here? So if I finish this function, we go here, here, return. Oh, we're only incrementing, probably. I think we just fucked up here. We are only incrementing if we're above the grid width. We forgot to do self x pause plus equals 1 here, which is a very important piece of this. A very, very important piece of incrementing. Okay, so now he finished, and if I refresh this guy, not this guy, do we see... So we do see some blue boxes, but we heavily fucked up, right? We just found the wrong fucking pattern. Yeah, that makes sense. That's just the wrong fucking pattern. So 1, it's actually supposed to be a 5x5 block, not a 3x3 block. So, oopies. And this should be light thing is also wrong because it's going to allow for this white thing to extend all the way. So this has to be x equals 0, y equals 0, or x equals 2 or y equals 2, or 3. And then 5 as well. So it's like, it's something more like y percent 2 equals 1 equals 0. That'll give us like black, black, black. It's not what I want. This is more like, come on, I know there's some sort of like elegant way to do this. I just can't, like, I'm not seeing it, you know? So here, 0, 1, 3. So percent 2 is 1. I mean, you could just like, you could just do percent 2 equals 1 and then trim out the sides. I guess that's, but it doesn't feel good. It doesn't feel good that way. If you did that they both have to be 1, you would get these corners. That's fine. Fine. We'll just say y percent 2 equals 0. Zero, 1. So you have 1 and 3. Fine. We'll just do y equals 1 or y equals 3. And x equals 1 or x equals 3. That's not right either, because we're going to be missing these ones. Dude, sometimes I just feel so fucking dumb. I feel like this should be such an easy pattern to mathematically generate, but I'm just not fucking getting there. I hate it. I hate it. Okay, so y equals 1 or y equals 3 and x is greater than 0 and x is greater than or less than 4. Ugh. Gross. And this is y offs everywhere. And then we do the same thing, but for the fucking other side. So now the other way is x, x, y, y. Gross. I'm not even sure that's right, to be honest. But you know what we do instead of thinking? We run our code and hope for the fucking best. Oops, we forgot to... We did do 0 to 5. Oh, it's 0, 1, 2, 3, 4, 5. Yeah, okay. Oh, but the box, we didn't draw the right box. Here we need to add lm width times 4 on all these. Okay. So that does look like we found them, right? Alignment, alignment, alignment. Yeah, it feels like we didn't really draw it anywhere else that we shouldn't have. So now what we need to do is we need to pull out all of the alignment sections and use them to determine if we should be skipping when we iterate. So I guess what we'll do is on our QR code construction, we'll say alignment positions. And I guess this has to be a dynamic array. And I also guess he needs a type associated with him. So maybe we'll just make a like point with x usize and y usize, and maybe we'll call it grid point to make it clear. Grid point. And this isn't how you write structs in this language. It's const grid point is equal to a struct. And then here we will have an array list of grid points. And I guess that kind of means that it probably makes sense for our alignment finder to return grid points. Just kind of, why would we do extra type conversion when we don't need to? So here he's going to have a point grid point, and we'll call this top left. And then when we return, it's just like TL is equal to this. Okay. So now when we construct our QR code, we can say, once we get through all this shit, we now have to try to find our timings. So var alignment finder is equal to an alignment finder initialized with all of this stuff. Gross, but you know, whatever. We don't have ROI here. This is going to be called QRrect. All right. Grid width doesn't exist here, surprisingly. So I guess here we need to pull out these guys, stick them here as constants. Right. And then we have them available to us. And then, oops, what the fuck did I just do? Down here, grid width is equal to grid width. And grid height is equal to grid height. And then here we're going to have to do something. These guys have to be also flagged as their types for the float from int or int from float to work out. And I guess we're just going to say alignment positions is equal to some array list using grid points initialized some allocator. I don't know if there's like a way to error out here, but I guess we could just like, for correctness, we can free this guy. Even though I don't think this is gonna like ever fucking happen. Mint positions equal to alignment positions, great. And then that means that this whole QR code thing has to actually have a deinitialize function now, so. That's gonna be annoying, but yeah. This sucks. This is something that I haven't encountered yet in this language, but that's fucking annoying. So the problem here is that like before now, this QR code did not have this constraint. And now it does. So now you actually have to go through and find every single usage of this guy and make sure that you're like deferring him. And there's no way to tell the compiler to like figure it out for you, which is really fucking annoying. And like I can imagine that being like a complete disaster if you were to use this as like, say you had like an array of QR codes. Now all of a sudden you need to know to find a function that calls with QR code as a type and then call dinit on each element. It would just suck. It would suck. Oh, and even if I just like grep for QR code, there's all sorts of places where it's around. Let's remove that arm test perf. Because it's used as like function arguments and stuff. So it's not even trivial to just like find all instantiations of it. That fucking sucks. I don't like it. But it does look like it's only a few places. It looks like we're calling QR code init directly every time, so it's fine. I guess maybe you could argue that you could find references of this guy, of the initializer, and maybe that would just kind of work itself out. Like, maybe that's not the end of the world. Yeah. No RAI, I think Zig considers that hidden control flow. Yeah, like, I understand that. That, like, makes sense to me. But I just hadn't considered this implication of it, which is that there's no way to easily propagate that change. It's just kind of a... I guess you could rename the type. If you rename the type and then tried to compile, you would probably find all the usages of it, which would be fine. Except if you were using it as a function argument everywhere by pointer, that would be annoying. But it might just be something you have to do. Blech. Okay. So while we find some alignment, find alignment marker. We append the position. Or let the GPA yell at you. I mean, but then you're back in like Python land, right? Where it's like, you don't want to have to run the code to find out where it's a problem, right? Like, that's silly. We have the information. It would be nice if you could like somehow mark a function as like being required to be called. I think that that's like kind of like a nice trade-off, but I just don't really know how you would implement that sanely. Yeah, I'm not really sure. Not really sure. Okay, so try alignment positions. We append the top left position. All right. Does that run? Yep, we're chilling. And so now all we need to do is in our data iterator here, wherever the fuck he is. Bit iter. Yeah, here we go. I kind of like worked on this code a little bit last night. This is so hard to get sanely, by the way. These conditions really like stack themselves up, right? So you just have like all types of conditions that will result in like different movements. And so I kind of like split them out into this, like, if we're out of bounds in Y, if we're in the top right finder, if we're in the top left finder, if we're in the bottom right finder, if we're in the timer pattern. Like, there's just all sorts of like rules in here. And I guess we'll just add one now. That it's like, if in alignment pattern, we will return, hey, the action that we want to use is for you to continue zigzagging. I'm pretty sure that's what we should do up on an alignment pattern. So now we're just going to have some function in alignment pattern. And I guess what this is actually going to have to do is it's just going to have to check every single one. So he is going to have to store the alignment patterns. So he's going to store these like grid points, I guess. Which means that this is going to be alignment patterns comes from the QR code alignment positions items. And he's just going to walk all of them. So he's going to say for align self alignment pattern. We're going to have some top left position. And we're just going to say if our x position is greater than top left dot x and our x position is less than or equal to top left dot x plus 5. We should factor out that 5. We have a bunch of constants somewhere. We can just throw it next to it. So here we'll say const alignment pattern size. And then we can just search for 5s in here. Alignment pattern size 5 5. Not this one, not that one, not these 0.5s, not that 5. Yeah, I think we're chilling. So plus alignment pattern size. So if this return true, and then we just do the same thing for what y. And then at the end of this, we return false. Boom. And then we can go to main, and we can go back to this stuff, and we can actually try to draw those boxes again using that same bit iterator and see if it like did a sane walk. Refresh. Not quite. Off by 1s in a few places. Also, we should be doing if x and y. So const x in alignment is equal to this, and then this is const y in alignment this, and then we say if x in alignment and y in alignment return true. And this was off by 1 somehow, which is surprising to me. I don't really understand why. Oh, maybe this is greater than or equal to here, and this is less than. Yeah, that makes sense to me. Okay, that's not bad. And then let's like look at the walk pattern around one of these guys. So he's coming up here, 32, 33, 34, 35, 36, 72, 78, blah, blah, blah. He skips over. So this should go 439 to 440. Great. This goes 776, 777, 7. Oh, this is coming down. So 4, 5, 6, 7. Great. And then on the way back up, we go 4, 5, 6, 7, 8, 9, 0, 1, 2, 3, 4, 5, 6. Hell yeah. Boom, baby. Feels fucking good. Okay, so theoretically, it looks to me like we've kind of hit all the right spots on this guy, and like maybe this should parse. Now, clearly, something fucked is going on here. So where did this come from? I can't remember where I pulled this from. I think it was from the Wikipedia page. I think it was one of these guys. So this is version 25. So that's this one. It should be this. And he says that it is supposed to be a QR code. Is it? Does it not say what it's supposed to say? 1 to 69 characters of ASCII text describing QR codes. Okay, so maybe at the very least, let's try to look at if it parsed like the length out correctly. So we can look at our data iter, and let's just kind of see what we get if we go here. So let's open up our GDB script and breakpoint here, and let's use the input of 1024, this thing. And GDB-x run GDB. Okay, and let's info locals. So we got a length of 9. No fucking way that's right. No fucking way that's right. Encoding 4. So encoding 4 is probably correct. Oh, hold on. I know what the bug is. We said we would ignore this problem and then get bit by it later, and we sure did. The size of the length field changes based off of the version number. I saw that somewhere. Length. Where does it tell me that? Was it here? No. Here? No. Maybe one of these pictures down below. These guys? Levels. Length. Yeah, here. So depending on the version, it's going to be a different number of bits. And it's also dependent on encoding. Oh, fuck me. So we're in version 25 encoding bytes. So let's just set it to 16 for now, unconditionally. And then we'll come back for it. So we can look at QR data. I just want to see if like the rest is working okay. So here, collect bits by some bit iter for length. So length is going to be a U16. Which means that this is going to be collect some sort of amount of U16s, and the shift field for a U16 is a U4. Oops. So I think this should build. And here he's expecting a U8 here, so we'll say U16. Great. And otherwise, it looks like maybe he's chilling. Okay. So that's fucked. Right, absolutely fucked. But at least the length field is longer. And can we at least maybe go back to our GDB script and info locals and see? So we got a length of 2416. And what do we expect to see? We expect to see 1269. Not good. Not good at all. Just out of curiosity, if we were to swap the byte order of that, I think it would be worse. We would see 7009, which is just fucking massive. Okay. I don't know what the problem here is, and do not necessarily think I'm going to discover what the problem is today. So I think I'm going to call it there. We're at an hour 52, which is close to the 2-hour mark, and we want to stream for close to 2 hours. I'm pretty happy with the progress here. So today what we got done was we fixed this like timing iterator thing so that as there's like drift from our initial estimate, it like automatically corrects for that and can adjust our grid size and now like walk a grid of full big QR codes. We also detected the alignment patterns here and updated our walk to walk around them, right? So the fact that we are handling this case well is like super sick to me, right? Like we have the iteration order going like skip up, skip down, and then like kind of like mush around this thing and then continue. That's so sick. I'm really happy with that. So feels good. Yeah, if you like what you saw, we stream most days at around 2 o'clock Pacific time for around 2 hours. It's 4 o'clock Pacific time now. So if you are watching live, that's 2 hours ago to now, most days. If you're watching on YouTube, there's a Twitch link in the YouTube description that you can swing by, say hi if you happen to be online at that time. If you're watching on Twitch, there should be a YouTube link and a GitHub link in the Twitch description. And on there you will find previous projects. So we've been writing a lot of Rust. We did like some operating system stuff. We did some like neural network stuff in Python. We've been doing some like terminal emulator, Git GUI, diff tool, virtual file system, you know, kind of just like low level things that I feel like are interesting to me at any given time. So if you want to check those out, those are available. Otherwise, have a good weekend and I'll catch you guys in the next one. Thanks for watching. Bye.